Hello friends, welcome to my channel. So today we are going to discuss where is my topic. So today we are going to discuss our next trade-off. So concurrency and parallelism. Where is concurrency and parallelism? Okay, here we go. Uh, so last time we discussed concurrency. Last time we discussed this horizontal and vertical scaling. Today we're going to discuss concurrency and parallelism. So if you are new, so this is a high-level design series. And right now we are at trade-off thing. So what is trade-off? Like the thing is we can't serve two things at a time, concurrency and parallelism. For example, particularly on this topic, right? So sometime we can serve concurrency, sometime we can serve parallelism, or both as well, depending on our sources and things, right? So this is a kind of a trade-off. We can't serve all things at a time, right? So we discussed already a lot of things, right? A lot of concepts, key concepts, building blocks, and right now we are at trade-off. So going away, going way, we're gonna discuss all the things, meaning LD as well. So very, very important for our interview questions for seniors or leads. So basically, just example, I just gave us some sort of demo interview and then I was asked, okay, rate limiting, right? So still, it's a lower design topic and we're gonna discuss everything practically, right? So right now we are at this. So let's get started. So one more thing, I have created notes as well, just like as this is our today's notes, very simple. Huh? So I'm not sure I committed or not. Let me commit once. Okay. So if you go inside this HLD, so you're gonna find all the topics just like as consistent hashing. So you will find the notes here. Okay. So likewise, I have created all the notes here to revise or if you have either you can come to my videos as well, right? So you'll get everything. So let's get started. So today's topic is our concurrency and parallelism. So first of all, let's start with some simple definition. Concurrency is about managing multiple tasks, dealing with more than one thing at a time. And parallelism is about executing multiple tasks, actually doing more than one thing exactly at the same instance. Concurrency, parallelism. We have to execute four tasks. It will execute four tasks at a one time. Okay. But concurrency, like that's right. Task one, switch to task two again, then might be come back to task two again, then task one, task two, something like that. Okay, switching. So this is a at high level, it's a concurrency, and this is a parallelism. So let's understand the example. So coffee shop has handling a five customer. Okay, she is concurrent. She takes an order, starts the espresso machine. Now switch task one, then switch to task two. Concurrency I'm talking about. Switches to hand another customer their change, check the milk steamer, moves back, moves back. She juggling all five. Okay, likewise, just doing this, doing that, this and that. Okay, and mm, now five cashiers at five registers. That parallelism. Okay. So just like as first of all, one person was switching one task, two task, three task, then again switching back to second task, then task four, task one, something like that. This is the concurrency. And when we have five members or five threads kind of thing, which will run parallel, dish, right? This is the parallelism. Like in Java 8, right? Uh, very good thing, right? Parallelism. So I will show you the example, practice example as well. So now, just like understand some more points. So concurrency is kind of a single core, okay, single threaded Java service using completable future, non-blocking IO, right? The CPU rapidly switches between the waiting, switching between waiting on DB, waiting on network, doing CPU work, something like that. Okay. So that's a concurrency. You get it right. Suppose you hit the query, getting like 1 million records. Will take some time, right? In the meantime, it will switches to another work, right? So this is a kind of a concurrency. Parallelism. Now, no real concurrency design. Running four independent batch job in four separate JVM. Okay, this is a parallelism. Four separate JVMs. Okay. Now, both the interesting area, a Kafka Consumer Group and partitions and thread across M cores. Okay, you have designed concurrency. Each thread independently manages its own consumer loop, offers tries. Okay, and hardware you give parallelism. Multiple cores actually executing those threads at once. Whatever I told here, right? Five threads executing, like we put hardware like that. Okay, and each is doing their own work. Consumer, offset, retries, whatever. Okay, so this is a both things. Like, okay, so now first of all you need to understand trade-offs, right? So if we have hardware restriction, we're gonna prefer with concurrency. If we gonna have no hardware restriction and we need a fast speed or like fast execution, then we're gonna go with parallelism. But make sure if we are going with parallelism, our cores like CPU should be good. Okay, otherwise it will not gonna handle all these things. So this is a kind of a trade-off, right? If you have hardware and in that and you have so many tasks to complete in some time, right? In time T, then you must go with parallelism. And if you don't have much solid hardware, right, and you can go like with little bit latency as well, then concurrency you can choose, right? So this is a kind of a trade-off. So when you're gonna use parallelism, when you're gonna use concurrency. Okay, so this is the main thing. Simple little things how you have to handle. Okay, dealing with many things, doing many things at a time. Dealing with many things, concurrency, doing things at a time. Anchored with hardware, concurrency is a simple program structure. Parallel requires multi-core. Okay, so for the example, if we take about executor service with a single threaded pool is a concurrency, but not parallel, but a fork join, splitting a large sum into a large gross course is the both, right? So something like that. Okay, so now you are clear with the concurrency and parallelism. Okay, now let's see example. Let's see example. Uh, how concurrency and parallelism works. So I created the example for you as well. So you can see, first of all, this is a concurrency. Okay, so concurrency, we have created new executor service. We are using executor service. So this is the interface, right? So by using this executor service, we created 10 threads. Okay, and then we are assigning some sort of ID, like we are performing some task based on some, it's an example, right? So we are executing some task by passing some task ID. Okay, so you can see this definition as well. So we are doing nothing. We are just we're just saying, okay, just sleep for 2 seconds. Simple. Okay. So now we have 10 tasks, kind of a 10 task. Okay. And each task will go here and there. Like I will show. Let's run this. Okay. So concurrency. So you can see the screen here. So have you seen task one started? Task time started 4, 7, 8, 6, 9, whatever. Okay. So, but here we have 10 tasks, we have 10 threads, 10 tasks. So speed very fast, right? So generally it is okay. Let me do one thing. Let me take it, make it 3 only. Then you can have good observation. Now you will see, first of all, task 3 started by thread 3, task 1 started by thread 1, task 2 by thread 2. Okay, then these are completed. Then again, thread 2 took task 5, thread 1 took 6, thread 3 took 4. Now, you can see 5 and 6 are completed, 4 is not completed. Now, 4 is completed here. Okay, so meaning, so where I wrote this, I wrote here, where we are performing task. Okay, so this is a kind of execution, right? So, three tasks, we have three threads, three tasks, they are working on it. Somehow they have completed, but here again, they are working on three tasks again, but somehow two completed, one is pending. But now here, if you imagine this thing, 4 was allocated to 3. Okay. What does it means? 5 and 6 were free. So 5 and 6 were completed. So they took that one, two took another two task. Right. Because they were completed. And 4 were not. So that's why 4 completed after. So likewise, now you are able to understand, right? Kind of a switching thing, right? Okay. So this was a concurrency. Now let's go to the parallelism. So here what I did, uh, I created two things, sequential and parallel, to make you more understand. Okay. So let's see the structure. Parallel mode, multitasking, executing similar, whatever I just wrote some for understanding. Okay. Sequential processing. What I'm doing here, if you see, I'm just generating data. They even just simple linked list, array list I'm creating, right? And uh, okay, so here, whatever I'm getting, that 1 million value here, then again, I'm doing some operations, right? So the purpose is I need to check the time, right? How much time it is taking for sequential. So this is sequential. Okay. Just I'm doing some looping, generating data, and then I'm again putting in the for loop, and then again I'm doing some sort of for loop things, scale root, this and that. So if I talk about parallelism, so I'm using here parallel stream, right? It's a very good to show, right? I'm using parallel stream and just generating data, and then parallel stream and done. And then I'm taking time. So let's see how much time it is taking for parallel stream and single stream. Okay, let me run it again. I ran the wrong, not wrong, previous example. So here we go. So if you see, sequential processing is taking 51 seconds, not second, milliseconds. Parallel processing is taking 13 seconds. Okay. So now this is a difference. Sequential, parallel. Whatever I was explaining here, uh, where is my pen? Okay. So parallel, right? Parallel, like we have multiple threads. We have multiple threads executing their own work. Suppose we have uh, 1 million task. Okay. So what it will do, it will split out these 1 million tasks into, if I divide by 6, so whatever the number will come, okay. Suppose I'm not good in calculations. So suppose uh, around 1. just to somewhere take 2. Okay, just make it 2. So 200K by this task T1 up to so on 200K by T6. Okay. So likewise, in parallelism, the task will get divided into like this. Okay. And then they will execute in parallel. But if I talk about concurrency, the same thing it will do if you create 6 threads, right? 200 task. But here we don't have division, right? So whatever we have, uh, here the number of tasks, so it will switch, right? Suppose it will perform, T1 will perform one task, then T2, T3, T4, T5, T6, right? Whoever get free, they will take another task. Whoever get free, they will take another task. Okay, like that, switching. They will get free, they will take task. Okay, not switching kind of thing, kind of they will perform. T1 is get free, then it will take another task. T2 get free, it will take another task. Okay. But here it's straightforward. So T1 will perform these, T2, T6 will perform these tasks. Okay. So this is the parallelism and concurrency. So I hope you clear this thing. And if you have any question, you can comment it out. And we'll meet in next video for our next topic. I hope this concept is clear to you. Concurrency and parallelism, very, very simple and important as well. Okay. So next video we'll discuss about long polling and web sockets. Again, important. Okay, but here this topic is very much important. So might be we'll see. So for now, I'm closing video for now. And if you're new, so subscribe to the channel, be with me, and we'll discuss a lot of things with a practical example going forward. Yeah. Okay. That's bye for now. Thanks. Bye.